Jackson, and I'm a part of Challenge 2016. Okay, so this second video is still a part of the first video assignment, and I'm going to read what the question says. So it says, to show that tan is not one-to-one on its whole domain, show that you can restrict the domain to define a function that is one-to-one and increasing whose inverse is arctan. Give the domain and range of arctan and show that it is increasing. So we're going to try to work this out. Okay, so what you see right now is the original tan. You can see all these real nice colors I did. You got the green, which is the limits, where nothing really exists there, and then the red, which is the actual graphs. So in the last video, we did go over like what one-to-one is, and we've already said that it has to pass the vertical and horizontal line test. So let's just try it with this to see if it's one-to-one. So clearly it doesn't pass one of them, but vertically it passes that one because it only touches the point once. If you were to like draw a vertical line, let me get a Sharpie. Okay, so vertically passes, touches only at one point, but then horizontally it touches a whole bunch of times, right here, right here, right here, right here. So it's not one-to-one. But there is a way. So now we're going to talk about restricting the domain. And so just to say, domain are all the x's. So that's what we're going to try to do. And this is what tan looks like restricted. You don't have a lot of the colors anymore. You only have the one here. So let's try a horizontal test on this. Horizontal, only once. Vertical, only once. So for tan to be one-to-one, we know that we have to restrict the domain. And so to figure out the domain, if you were to want to figure it out, you just look at where all the x's are. So clearly the x's start here at -1 and go to 1. So if you were to write this in interval notation, it looked just like this, with the -1 right here and then the 1 right here. So the domain is all the x's. If you were thinking about it opposite, the range is all the y's. So we're looking at this axis right here. So if we're trying to figure out the range, you're going to look at where the y's are. So clearly it stops right here at the -π/2 and ends, well, it kind of goes above it, but just for the sake of what's right, okay, it ends at the π/2. Just imagine like that just cut off right there. So tan restricted, the domain is from -1 to 1, and the range of tan restricted is -π/2 to π/2. And when you're writing in notation, you have to remember to always put the least number on the far left and then the highest number, the greatest value that x could possibly be, on the far right. And now we're going to talk about tan inverse. I can get the page. So tan inverse can also be referred to as arctan. And before we switch, let's just go back and make it noted that it is increasing simply because the graph is going up. If it were decreasing, the graph would be going kind of like this. Not exactly, but it'd be going down. So that would be decreasing. There's the opposite, but this is increasing. So now back to arctan. Arctan tan inverse. The inverse of a function is essentially just its opposite. And so this is what the graph of tan inverse will look like. You still have your limits right here. Yep. And so it is also increasing. Let's draw it this way so you can visualize. It's going up. Just the same as the regular tan graph. But now let's go over its domain and range because it is different. So like we discussed in the last part, domain is all of its x's. Clearly, this will never touch this line. And so it will continue going to the left and continue going to the right forever or infinitely. So we could say the domain is all real numbers, or if we were supposed to put it in interval notation, negative infinity to positive infinity. And now for the range, you just look at all the y's. So it goes from negative pi over 2 to pi over 2. And then you write that in interval notation just like this right here. So the domain of regular tan was negative 1 to 1, while this one is negative infinity to positive infinity, just because it sort of flipped. But interestingly, the ranges are the same. Well, of course, because of the unit circle, but for other reasons too. But simple as that, that is the graph of tan, tan restricted, and the inverse of tan.